Hello everybody. Today we will explain all types of NAT, network address translation, where do we use it, why do we use it, and how to use each type of network address translations. Uh, the types of network address translations to be discussed today are static NAT, dynamic NAT, port address translation or PAT, and that is one of the most common usage of NAT. And in the end, we will discuss about port forwarding. But first, let's explain the scheme shown here, and then we will start configuring NAT. Inside the green circle that we see here, here is the green circle, there is the network of the company one. We have called this router here company one, and inside of this green circle is an FTP server with the IP address of 192.168.1.100, and there are two PCs shown here, but the idea is a lot of PCs might be there. The first one has the IP of 192.168.1.10, and the second one has the IP address of 192.168.1.20. But we will be using here, this is the NAT border, sorry, inside here will be NAT inside, and outside there will be NAT outside. Okay, we have also the configurations here in the company one router are already made, not the NAT configurations, but the other basic configurations, the gigabit Ethernet 0/0 with the IP address of 192.168.1.1, and the gigabit Ethernet 0/1 with the IP address of 1.1.1.1. We also have configured a static default route toward the ISP1, Internet Service Provider 1, with the AS number 65,000. In the configurations here, this area here for us will represent the internet. We have the first internet service provider, then we have a second internet service provider. Somewhere here we have added a server, which we will use it as DNS server, and also we will reach it through the domain www.google.com just for the purpose of testing. Configurations in router ISP, ISP1 and ISP2 are also made, all of them. These two routers together are connected via BGP, and this router here is connected to a home router that this area here will represent our home. So this is basically our office, and this will represent our home. We have a PC in our home, and we will use our home network for some NAT translation purposes to access our server using different types of NAT. So both server and PCs have access to internet right now. Also, this PC here have access to internet. This one here is everything done because this router here has the NAT enabled by default. So if I ping from 192.168.0.100 to the Google server, the ping will work perfect. So let's open command prompt and ping 8.8.8.8. The first is going to be a timeout because it's the ARPA being made, and the ping it's okay. So the connection is okay, but if I try to ping from this server here, this PC in here, the ping will not succeed because the only IP known by these routers are the public IPs. So it is known only the IP 12.12.12.2. So if I try from here to ping this address here, it's not going to work because it is a private IP. So let's try it. Ping 192.168.0.100. The ping is not reachable. So the router replies, our router, ISP2 replies to server and says that the destination is not reachable because it is not in its routing table. Show IP route. So 192.168 is not here at all. So all the configurations are done. So now let's start configuring the path here, port address translation. This is the first type of NAT because we want to give permission to the PCs that are inside the office. We want to give them access to the internet. Before making this configuration, these PCs cannot access the internet. Let's try ping. The ping will not succeed. So, to make it happen, we will configure port address translation in here. Basically, we will be telling our router here, company one router, that all these inside IPs, when they try to go out to the internet, you have to translate them to this public IP because this is the IP that all other devices here in the internet know. They do not know these IPs inside. So to be able to communicate to the internet services, the router should replace those inside IPs with this outside IP. And the moment that the NAT is taking place, what happened to the original packet? Let's suppose that we will be pinging from 192.168.1.10 from this PC to this server. So the source IP address will be this, destination IP address will be this. So the first packet that is created is this one with the source IP address of 1.10, destination IP address 8.8.8, source port. It's a commonly generated port. It's greater than 1098. So this is a random port we have chosen is 1512, and the destination port is the web port 80. After the packet is netted, the packet changed the source IP address to the IP address of the router 1.1.1.1. But the question is, how will the packet know where to go in the inside network when it comes back from this server? So this server replies to 1.1.1.1. How does the company one router knows to send the packet exactly to this PC here? In fact, every router that uses NAT has a table which it stores these types of connections. So 192.168.1.10 with the source port 1512, it is sent to the 1.1.1 1512. So when it comes back the packet with the source with the destination port 1512, the router knows to send it to 192.168.1.10. And that is the reason we call this type of NAT PAT, so port address translation. So let's start configuring PAT, port address translation. So configure terminal. First, we want to create an access list that will allow all the inside IP addresses to be netted to the outside network. So access list one, a standard access list. Access list one permit 192.168.1.0.0.0.255. So all the IPs that are in this range. So now we will go to a different NAT configuration. We will be configuring static NAT now. Static NAT configuration. Why do we need it? Where is the configuration done, and how to configure it? The why is one of the many things. For example, is if we want to make our FTP server inside the office to be accessible from my home network here, because I might want to work from my home and still have access to this server in the office, and how the scheme is now and the configurations. My PC in home has access to internet but cannot access anything inside the office. FTP server also has access to internet, but its IP is masked with the public IP of the router 1.1.1.1. So my home PC has no way to reach inside network of company 1. So to make it happen, we are going to make a static connection telling our router that every time you have a request for the IP address of 1.1.1.1, send it to our FTP server 192.168.0.100. So let's make it happen. Here are the configurations. It's just one line, configure terminal, and the configuration is this IP not inside source static. Inside local IP address, that is the IP address of the FTP server, that is 192.168.1.100, and then the inside global IP address. So what is the IP? What is the outside IP address that we use for this? It's 1.1.1.1. So we set to our router that every time you have a connection for this IP address, send it by default to this IP address. So let's test if this one works. So let's open our command prompt and make ftp 1.1.1.1. Okay, welcome to PT FTP server. That is this server here. The default username and password are Cisco. And we are inside the FTP server right now. And now we are out of it. So the static configuration is now made. The third NAT configuration we are going to make is the dynamic NAT. For this configuration, we need more public IPs than just one. So the why do we need this type of configuration is the reason because we might have a lot of devices in here, not just three, but for example, we might have more than that. Let's say we have 500 devices to want to get internet access to the internet, and Cisco recommends only 128 private IPs to be translated to a single public IP, and in this case, we at least need four other IPs to secure internet for all 500 devices that we have here. So let's say 500 devices divided 128 private IPs for one public IP. So it is at least four other IPs. These IPs should be purchased to our ISP, that is this service provider that we are connected here. And for this example, we have purchased another subnet, /29 subnet, or with 8 IPs in it, in the range of 22.22.22.0/29. For this configuration, so let's start configuring it. First of all, the access list, we have already configured it. Show access list. It is this one here that allows all our inside IPs to be translated to our outside. So this is the first step, to create an access list, but we already have it. The second step is to determine the public IPs to which our inside IPs will be translated outside. So first of all, we have to delete the first path we configured in the first example. So we'll make the command no IP not inside source list 1 interface list 1. Oh, it's just enough. So IP not pool. So we are creating the pool for our inside IPs to be translated in our outside pool. So the pool we have purchased from our internet service provider is 22.22.22.1 to 22.22.22.7 is the last IP. So we have to say 6 mask. Oh, we have not told name, not pool. And now we have to specify our net mask. Net mask is 255.255.248. Very good. Now we have to connect our access list to our NAT pool. IP NAT inside source list 1 pool NAT pool overload. So with the command overload, we are telling our router that with one public IP address, you should send out more than just one private IP address. Because if we don't use the overload command in the end of this command, then our router will send out only 4 private IP address to this 6, only 6 private IP address to this 6 public IP addresses that we specified right here. So let's see now if our router will be using these ones to be translated to our outside network. Let's ping Google again. Ping google.com. Okay, everything is good. Everything is good. And let's see NAT translations here. Show IP NAT translations. We see now that the IP address 192.168.1.10, that is our PC here, is being translated to the first dynamic IP that we have purchased from our ISP in this pool, NAT pool here. So we told why we use it and how we use it. Now, the last thing we will be discussing here is the port forwarding, which is very useful in the cases we do not have enough public IPs. The why we need port translation is, let's bring back static NAT purpose that we used earlier. We said that if we want work from home and still have access to our FTP server, so same thing will be achieved also in this case, but in this case we'll only use our router public IP and use it to access our FTP server by making a static port forwarding. So basically we will say to company 1 router, whenever you receive a request on the IP address of 1.1.1.1 on port 21, you just forward that request to our inside IP of 192.168.1.100 on port 21. So we are not blocking the entire requests on this IP, but only on port 21. So when I'm from home, I type 1.1.1.1 on port 21, and then that request is sent it here. So let's delete the first static NAT we made. Configure terminal, no IP NAT inside source static. And we are going to say to eliminate the things we did before. Inside local was 192.168.1.100 and public IP was this one. So no more static. So if I go here and type FTP 1.1.1.1, it's not going to happen. Error disconnecting, no peer. So it doesn't work. So I have to make a port forwarding. So to make the port forwarding, I have to do IP NAT inside source static TCP, because FTP protocol uses TCP protocol. Inside local IP address 192.168.1.100, and watch port 21. Inside global IP address 1.1.1.1, which port 21. So we are only using the port 21. So we are only going to occupy this IP address for the port 21 to forward it here. If we had another server, let's say for example, let's add another server here, that we call it web server, that we use it only inside the company. And this server has the IP address of, let's set, let's add an IP address of 192.168.1.200, and the default gateway 192.168.1.1 in the server, but it doesn't need, however, and we're going to use this as a web server. So if we go to our router and make another static NAT, side static, the web protocol uses TCP also. Now the inside IP address will be 192.168.1.200, that is the web server. Watch port, which port? 80, that is web port. Which is the global IP address? Same IP address. What port? Port 80. Okay, so now when I go to my PC and open command prompt and say FTP 1.1.1.1, it sends me to this FTP server right here. And I can log in Cisco. I am in. But if I go here in the same PC, open the web browser, and type 1.1.1.1, this time it is going to send me to the web server. So I hope you did understand why we use port forwarding and how we can profit from it. So we use the same the same public IP address to make static port forwardings to send whatever traffic we want to whatever server we want to access it from the outside network. So we told our router, when I have an FTP access request, you send me here to FTP server. When I have a web server access, you send me here. Hope this has been informative for you. Thank you for viewing. Don't forget to follow. Thank you. Bye.